Everyone. Today we're going to look at some more examples of how to use expected value, okay, where they apply, and one really good real world situation. So once again, expected value is the average outcome that'll occur. Okay, so it's the average outcome that should occur during a single trial. It may or may not be reasonable to happen on that exact trial, and we'll see what the averages are today. So we looked at this die problem yesterday. So if you roll 1 or 2, you get $15. 3 or 4, you get $20. And you roll 5 or 6, you lose $30. So there's 3 different events or 3 different possibilities. So let's look at them. So you could either win 15. So there's 2/6 or 1/3 chance of that. You could win 20, or you could lose 30. And each of these in this case happens to have the same probability because it's 2 out of 6 ways for each to happen. So the expected value, okay, there's 1/3 possibility of winning 15, plus there's 1/3 possibility of winning 20, plus there's 1/3 possibility of losing 30. And when you add this up, we can let a calculator do it for us. It becomes 5/3, or you can convert it to money. It's $1.67. And it's positive this time. So you should expect to win an average of $1.67 per roll. So this would be a good game to play. Okay, roll a bunch of times. Hopefully you're lucky enough that the average falls right and you start winning a lot of money. Now, some of you are going to have to start thinking about car insurance. Car insurance, you have multiple options for the annual premium and the deductible. So what a deductible is that's the first amount of money you pay in if you get in an accident and you have to repair it. So for example, in option B, you pay $447 per year. If you get in an accident that costs more than $200, you pay the first $200 and then the insurance company pays the rest. So now if there's a 10% chance of needing repair annually, we can figure out the expected cost of each option to figure out, even though option A may be the most expensive up front, is it the most expensive in a year if there's an accident? So 90% of the time for option A, you're just paying the $480, and 10% of the time you're just paying the $480 as well because you don't have a deductible. So you're just going to pay $480 and that's it. No matter what happens, you pay $480. Now, option B, 90% of the time you're just paying the $447, just your annual premium. But then 10% of the time, you're going to have to pay the $447 plus $200 to pay your deductible because you got in an accident. So that would cost you $647 total. And the expected value of this would be that you're paying, on average, $467 a year. Because you're either paying $447 or $647, and you're a lot more likely to pick $447. Now, option C, 90% of the time you only pay your premium, and 10% of the time you pay your premium with your $500 deductible. So, in this case, this one only averages out to an expected value of $452 a year. So if there's a 10% chance of needing repair annually, option C is the cheapest. Now, depending on what the percent chances, the probabilities, that affects the expected value. Okay, there's another problem in the examples that you can try out. I think that it says 17% chance. You can play around with a percent chance. Maybe you're a terrible driver, you get in an accident a lot, so you make a 25% chance, and then see which one has the lowest expected value, because that's what we're looking for. We're looking to pay the least. In this case, option C would be it. And that's how we use expected value for something like car insurance.